The first problem, 49 to the half, if we had to write it with an appropriate root, then that would be the square root of 49. These two mean the same thing. The square root of, which means the second root of 49, is 49 to the half. So we go 49 is 7 squared to the half. Now, the rule of exponents says a to the m whole to the n is a to the m times n. The same rule works for rational exponents as well. Rational is fractional. So that would be 7 to the 2 times half. When you multiply the two cancel each other out and you get 7 to the 1. So the square root and the square inside cancel each other out. We've seen that, and another way of doing that would be to use exponents, and you get 7 to the 1. Negative 49 is the square root of negative 49 to the half is the square root of negative 49. Remember that if the denominator of the exponent is even, so this is the second root, this would be undefined. When there's a negative number inside the radical sign, then that is undefined. What if we had the fourth root of 49? Same thing. 49 with a negative 49, sorry. Negative 49 to the 1/4, undefined. The sixth root of negative 49, any negative number, again undefined. So if there is an even root then of a negative number, then that is undefined. But if you have the negative of, and 49 is what is raised to the half, not the negative, so that would be the square root of 49, which is perfectly well defined. It is the negative of 7 squared to the half. And now that is the same as 7 to the 2 times half, because a to the m whole to the n is a to the m times n. You multiply the exponents. So that is the negative of 7 to the 1. The 8 to the 1/3 is the same as the cube root of 8. Now that is 2 cubed whole to the 1/3. The cube root and the cube cancel each other out, and your answer is 2. Use exponents if you're confused about the cube root or the square root. Now, the next thing is negative 8 to the 1/3 is the cube root of negative 8. Remember, the cube root of negative 8 is a negative number. If this is an even root, then that's when it's undefined. If it's the square root or the fourth root or the sixth root, then the negative root would be undefined. But if it's a cube root, then it would just be the negative of 2 cubed whole to the 1/3. So cube root is the same as the rational exponent 1/3, and that is negative 2 to the 3 times 1/3, and that's equal to negative 2. Let's look at the next one. 64 over 125, the whole to the 1/3. 64 is 4 cubed. 125 is 5 cubed. 5 times 5 times 5 is 125. 4 times 4 times 4 is 4 4s are 16. 16 4s are 64. Whole to the 1/3. Now that is equal to 4 to the 3 whole to the 1/3, 5 to the 3 whole to the 1/3, and that's equal to 4 to the 3 times 1/3 over 5 to the 3 times 1/3. Multiply the exponents because of this rule, and that's equal to 4 over 5. Now what if we broke down the 64 completely into its prime factors? 64 to begin with is 8 times 8. We know it's 4 cubed, but let's see if this can be done. Eight is 4 times 2 times 4 times 2, and this is equal to 4 is 2 times 2 times 2, and then 4 is again 2 times 2, and then there's another 2. So this is 2 to the 6th power. Now let's redo this problem. What if, just to see how it would look like if I had broken down the 64 completely. So this would be 2 to the 6th, and 125, if you break it down, the prime factorization is 5 times 5 times 5, which is 5 cubed. So anything inside the parentheses is raised to the power of 1/3. So each number inside the parentheses has to be raised to the 1/3. And the rule is this: a, b to the n is a to the n, b to the n, and same way a over b to the n is a to the n over b to the n. So that's exactly what we're doing here. Now we're going to use the rule a to the m whole to the n is a to the m times n. So that is equal to 2 to the 6 times 1/3 over 5 to the 3 times 1/3. So this is equal to 2 squared over 5. So 2 squared over 5 is the same as 4 over 5. Notice we get the same answers no matter how we break down the numbers. Now let's see how this works. If you want to simplify an expression like this, first factor that completely. 9 is 3 times 3, which is 3 squared, whole to the 3 halves is equal to 3 to the 2 times 3 halves. Cancel the 2's and you're left with 3 cubed. And that is 3 3's are 9, 9 3's are 27. Let's look at the next one. 25 to the 3 halves. Simplify 25 completely, and that is equal to 5 squared whole to the 3 halves. So factor this completely and you get 5 squared. So this is the prime factorization. Now this is equal to 5 to the 2 times 3 halves. Cancel the 2's and you get 5 cubed. 16 to the 3 over 4. Breaking down the 16 completely is 16 is 8 times 2. 8 is 2 times 2 times 2, and then there's another 2. So that's 2 to the 4th. So 2 to the 4th whole to the 3/4 is equal to 2 to the 4 times 3/4. The only time you multiply exponents is in this sort of a situation. The 4's cancel and you get 2 cubed, which is equal to 8. 81 to the 3/4. Break down the 81 completely. 81 is 9 times 9. That is 3 times 3 times 3 times 3, which is 3 to the 4th. So this is equal to 3 to the 4th whole to the 3/4, and that is equal to 3 to the 4 times 3/4. And cancel the 4's and you get 3 cubed. 3 3's are 9, 9 3's are 27. 27 is 3 times 3 is 9, 9 times 3 is 27. So 3 cubed to the negative 1/3. The rule of exponents is exactly the same, whether it's rational numbers, positive, negative, whole numbers, just anything. All you have to do is multiply these two. The 3's cancel and you get 3 to the negative 1. So the meaning of a negative exponent. So if I say 3 to the negative 1, this just means flip the fraction inside, and that is 1/3. Another way of looking at it is 3 to the negative 1. Let's write it as 3 to the negative 1/1. We move this exponential term from numerator to denominator, and the minute we do that, you have 1 times 3 to the positive 1. Moving a number from the numerator to the denominator or from the denominator to the numerator changes the sign of the exponent. So suppose I have 1/2 to the negative 1. I can move the 2 up and it becomes 2 to the positive 1. So changing the position of the number changes the sign of the exponent. Now suppose I have 1/3 squared and I want to move the 3 squared up. What changes is not the sign of the number, but the sign of the exponent changes from positive 2 to negative 2. Now same thing here. 9 is 3 squared to the negative half is equal to 3 to the 2 times negative half. The 2's cancel and this is equal to 3 to the negative 1. Move the 3 to the negative 1 to the denominator and it becomes 1/3 to the positive 1, which is 1/3. 81 to the negative 3/4. 81 is 3 to the 4th power. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So this is 3 to the 4th power whole to the negative 3/4, and that's equal to 3 to the 4 times negative 3/4. Cancel the 4's and you get 3 to the negative 3. Move the exponential term down to the denominator. 3 to the negative 3 is like 3 to the negative 3/1, and that becomes 1. The numerator becomes a 1 and the denominator becomes 3 to the positive 3, which is just changing the sign of the exponent. So that's equal to 1/3. 3's are 9, 9 3's are 27. So this is similar. 27 is 3 cubed. 8 is 2 cubed whole to the negative 2/3. Whatever is inside the parentheses, whether it's multiplied or divided, just multiply each of those exponents with the exponent outside. So that would be 3 cubed whole to the negative 2/3 over 2 cubed whole to the negative 2/3. So this is equal to 3 to the 3 times negative 2/3 divided by 2 to the 3rd times negative 2/3. Cancel, cancel, and you get 3 to the negative 2 over 2 to the negative 2. Now we do not like negative exponents, so we're going to move the 2 up, which will make the exponent positive. We'll move the 3 down, which will make the exponent positive. So that when the 2 goes up, change the sign of the exponent. When the 3 comes down, change the sign of the exponent. So your exponent is 2, positive 2 in the numerator and denominator. So that's a 4/9.